Hi everyone, today I want to highlight Y42's most impactful technical innovation, and that's virtual data builds. So I've pulled up the source here. It's a Google Sheet that shows a bunch of orders. So I've got an order ID, a name, and an amount. And imagine we've got a wrong row in here. So an invalid order ID, minus 99. And we expect these to just be sequential going up. I've pulled up a fresh Y42 space and created a new source asset. So this ingests the Google Sheet with our columns here. And through the ingestion, it ends up in Snowflake. So if we go here, we've got my new pipeline here, and then we've got a table, and here we can indeed see the erroneous value pop up. So Douglas Adams has an invalid order ID, and we want to catch this. So of course this happens all the time. We ingest some data, there's wrong data in there, and we want to clean that up and actually prevent it from showing up in our dashboard somewhere. So normally we would create a staging model in a traditional pipeline. So let's do that here as well. Generate staging model. There we go. And we can write a query here. And we could do a filter here. So for example, where true and our order ID is not null. And our order ID, we expect it to be larger than 0. We can preview this data. Might get a typing error. No, actually that works. Cool. So here it will be filtered out. We don't see the minus 99 show pop up. So that's good. We can commit and push this. So let's say transform. Filter out row order IDs. There we go, compilation successful, and now we can run this part of the pipeline. So let's build only this model. And there we go, after only 11 seconds our build is now green, and if we head over to Snowflake, then we also see our new view pop in here. There we go, staging row orders, customer order, and we might as well query this for good measure. Go, query. And as you can see, Douglas Adams has now been filtered out. So this is all well and good. This is a very simple pipeline, and this would work as you would expect it. But let's say that we want to introduce some tests to actually also verify that everything's going correctly. Because we may at some point get a few null values in our source data, or we may get some duplicates. We filtered this one out already, of course, but we haven't accounted for these types of errors. And normally what would happen is that we would introduce data tests. Now in Snowflake we can't actually throw errors, but we could do this in our ingestion. And then our pipeline would run, and this table would get overwritten. And at that point we would run our tests, and then our test would fail, and we would know, hey, now we have wrong data in here. And then we can take measures to account for that. The problem is that at that point, all this data in the data warehouse has already been overwritten. So you would already see the duplicate values here, you would already see the null values in here, and there's no way to recover from that because we can't just go back and take a look at the old data, at least not in an easy manner. And that's the problem that virtual data builds try to address. So what would that look like using Y42? I've done a tiny bit of homework off screen to rename the pipeline we've been using thus far. So as you can see, it's now called traditional orders. And let's see what we can do with the power of virtual data builds with the Y42 pipeline. So if we use Command K, we can create a new model. There we go. And let's call it a SQL model, and we'll call this one staging orders. And we can copy paste the code we had earlier, but instead of pointing to traditional raw orders, we will point to Y42 raw orders. And then in here, we also want to point to, let's see what the name of this is, just orders. There we go. And as you can see, Y42 automatically parses in the dependency. We can commit and push this. And up until this point, this is just code transformation or an addition in the code. So let's call this one create staging model. And that means that, well, this is committed, nothing still happens in Snowflake. So of course this is the data, that's the materialization that Y42 refers to. but we haven't materialized this yet. So if we now build our pipeline, we can select our new source model here and use plus to go downstream. Only at that point will we start seeing this data in Snowflake. And there we go, everything is now green. And if we head over to Snowflake, we can refresh here in the main, and then we should see, we've now got traditional orders and we've got our orders, and of course corresponding views as well. So that's how the build works. Now let's start using some of the magic in Y42. So how about we add a data test? So if we open up this here, we can take a look at our columns, we can sync these columns, and it will retrieve the schema from Snowflake. And we know that the order ID always has to be unique. So let's add a unique test here. There we go. Commit and push this. Again, this is just a change to the configuration in code. Add unique test to order ID. And if we go back to our input data, for example, we can add a new one here. Let's say that I myself place an order for 50 euros. As you can see, the staging orders here is now yellow. It's stale due to unbuilt changes, and that's of course the data test we just added. So let's ingest our data, and let's say that we want to do the orders and everything downstream again. And let's see if the data test succeeds. And there we go, we're all green. So let's take a look at the run here. So we built our source here, and then we built our staging model. And if we look at staging model specifically, we can see that we first did the materialization, and then we ran the column level tests. So the uniqueness test we added earlier. So let's take a look at what actually happened under the hood here. Because our pipeline run is green and everything works as expected. But due to virtual data build, some stuff happened under the hood that I want to highlight. So if we take a look at our run here, this is the build of our source data. So we've got our build ID over here. And if we copy this, we can use it later on. So let's head over to Snowflake. And as you can see, the newly added row that I added earlier is now in here, of course. And that is to be expected. And if we take a look at our pipeline, if we go over to main here, we can also take a look at the views. So our staging view has been updated as well. And that points to the right virtual data build. Now, what are these virtual data builds? Because thus far we've only been looking at the main schema over here, but there's also something going on over here. And if we take a look here and go to tables, then we see a bunch of tables here with hash IDs. And these correspond to the build IDs that we saw earlier. So this one starts with BC1, and indeed there's a table here starting with BC1. So this is the virtual data build for the pipeline run we most recently executed. And because the pipeline run was green, everything went correctly, Y42 automatically promoted this build, the last successful build, to the production build. And the same is happening for the views. So this is the most recent successful build for the staging views. And if we take a look here and head over to views, for example, staging orders, view definition, then we can see that this view now indeed points to the last successful virtual data build. And this is what's happening under the hood. So Y42 will do a virtual data build. It will create a zero copy clone in this dedicated schema over here. Then it will run the tests, and only if the test succeeds do we promote it to the production build. And what that means is that from the production build we will get an instant pointer to the virtual data build over here. And that way we can ensure that our tests have to succeed before we let data go live and let data show up in our analyst dashboard, for example. So let's see how we can use this to catch bad data in the unhappy flow. We're back in Y42, of course, and remember how we added a uniqueness test in the staging model over here. So the order ID has to be unique. That means that if we head over to our source data, and we can maybe add a new row here. Let's say we've got a duplicate value, or a few of them. And of course we want Y42 to catch this. So we now have wrong data at our source level, and that means that if we build our pipeline from here, let's select just this one and all downstream models. That means that our build should now fail, because we will still ingest the data and we will get the duplicate values, but at this point we expect it to turn red. So let's wait for that. There we go, our build is now ready, and just like we expected, the source is green and the staging model is red. So if we zoom in a little bit here, of course we didn't put any tests in the ingestion, so that is green as expected. And the staging order is red because if we take a look, the materialization is ready and we can view that later on in Snowflake, but the column level test failed because we don't have we do have a row in there that isn't unique. Now let's head over to Snowflake and see what that looks like. So this is our source, and if we execute this, then we will see our duplicate records over here. And if we now head over to here, we will see that the table is indeed including the duplicate records, but our views, there we go. Our view won't show these duplicate records. And that's because this one is still pointing to the last successful build. So if we take a look at the view definition, this ID hasn't changed. It's still pointing to the last green build. That's this one we ran earlier. And if we take a look here, then this is the most recent build ID, the one that failed because of the data test. And that one we can still find in BigQuery, in Snowflake. Which one was that? The 473. Yeah, that's this one. View definition. And this is the definition that doesn't get promoted to production status because of our failing test. Now, the cool thing about how Y42 uses these virtual data builds is that as data engineers, we are well aware of what's happening. So if we head over to Y42, we can see the stuff that's broken. We can set alerts to be notified when stuff breaks. Even though we've got all of that, these virtual data builds ensure that our bad data never goes live. So even though we've got a table over here, the production version of this still points to the last successful build, the ones that are still green. And that means that any dashboards built on top of this, that a data analyst might be looking at or a business analyst, all of that won't reflect our breaking data builds. I think that's really cool because it does allow us to work out fixes quickly as engineers while ensuring that our business doesn't fall flat on its face due to missing or bad data quality. Now, one final thing I want to show you is how virtual data builds don't just help us in our regular pipeline runs, but also in our development. So, as you may have noticed, we've been working from the main branch all this time. But of course, if you've got a data team with multiple data engineers, then you're constantly updating your pipelines, doing development. And what's really powerful is that all of this is Git-based. So each virtual data build ties into a Git commit. And we can create a new branch here. So let's call this dev1, for example. And now if I want to make changes, then I can work in my development branch and my colleagues can work in their own respective development branches. So let's say I want to make some change to my pipeline here. So for example, staging orders. But we don't really need the ID because it's just a row ID and I only need the order ID. Then I can commit and push this. So transform, remove row number. And because this is happening on the development branch, even if I build this, it won't affect the production builds. So compilation is successful. Actually, let me just quickly clean up the breaking changes here. Head back, and we can trigger this again. There we go, everything is now green. And if we take a look in here, we can preview the data to see that our ID has indeed been removed from the columns. And the cool thing is that this is only happening in my own branch environment. So if I head back to main, then this is the production data that people will still be seeing, which is now sadly red. But because of how this works and virtual data builds being made for every branch environment, that means that me and my colleagues don't need to work out, hey, who's working on that table? Everyone has their own separated development environment without needing actually separated development environments. So we don't need to duplicate our entire data warehouse setup to have dev, staging, and production data. All of this just works through branches. Now, let's see what this looks like if we merge this in. So from here, we can easily create a merge. We want to merge dev1 into main. Let's merge this in. And because the virtual data build already exists, the refresh on Snowflake should also be automatic or should be instant. So let's take a look at it again, and let's take a look at the main views. So staging orders over here. Actually, let me just query that. Y42 main dot staging orders. There we go. And let's take a look at the results. As you can see, the merge was instant. So the duplicate entries have been removed, even though that up until the merge, right up until the merge, they were still here. And that really speeds up your CI/CD process as well, because in a traditional pipeline, you do your pipeline changes, you run it on dev, you verify that everything works on dev, then you merge in your code changes to production, run the pipeline again, and that can take very long for longer pipelines, and only then do you see the updates. So yeah, that's another added benefit of virtual data builds. And I think those two together, so on one hand, preventing bad data from ever going live, and on the other hand, supercharging your CI/CD, is what makes this probably the coolest technical innovation on Y42.